A triangular gate has its vertex located 2 meters below the water surface. The gate has a base width of 1.2 meters and a height of 0.9 meter, with the base oriented parallel to the water surface. Interpret muna natin yung figure. Triangular gate. Base of the gate is 1.2 meters. The height is 0.9 meters. The base is parallel to the water surface. Okay, kung tingnan natin to sa side view, ang sabi din dito, triangular gate with vertex. Ito yung vertex. Situated 2 meters below the surface. Okay, so obtain the force acting on one side of the gate. What is the location of the center of pressure from the vertex? And obtain the normal force at vertex to open the gate if the gate is hinged at the bottom. Okay, balik kayo dito. So, normal force acting on the gate. If this is the side view, ito yung ating, hydrostatic force. So, take note that the hydrostatic force will not act at the centroid. Hindi po siya mag-act sa centroid ng cross-section or area. It will be acting at the center of pressure. Ang center of pressure, parati ang below the center of gravity of the area. Parati siyang below. Alright? Now, ito yung mga properties na kailangan po natin sa pagsosolve ng hydrostatic force. Kailangan natin makuha yung distance ng centroid galing sa water surface and tatawagin siyang barred h. Ang distance between the center of gravity and the center of pressure is our eccentricity. Okay? First, we need the area kung saan tatama ang hydrostatic force. Well, obviously, taamaan niya tong area ng triangle. And the area of the triangle is 1/2 of the base, that's 1.2. Height is 0.9, that's 0.54 square meters. Okay, aside from that, ang barred h, what's the value of barred h? As you can see, ang barred h is the vertical distance from the water surface to the center of gravity. So, that will be 2 plus this distance. Okay, basic shape. That's a triangle. What is the distance of the center of gravity from the vertex of the triangle? Diba? That will be 2/3 of the height, 2/3 of 0.9 meters. That's 0.6. Meaning, the barred h is 2 meters plus 0.6. Have 2.6 meters. Okay, meron din tayong tinatawag na barred y. Ang barred y naman is the distance from the water surface to the center of gravity but along the plane. Okay, for this case, along the plane siya, daw sa plane na tinutukoy natin. For this case, ang plane natin is vertical. Meaning, ang barred y is just barred h. Okay? And the moment of inertia about the centroidal axis of the triangle, remember, it is dh cubed over 36. Hindi verto ba? You are dealing with triangle. B is 1.2. H is 0.9 over 36. Remember, triangle over 36, so hindi over 12. So, if you calculate for that, that will give us 0.0243 meters raised to 4. Okay, hydrostatic force acting on one side of the gate, that's gamma barred H area. Of course, gamma water, kasi nasa tubig yan. Ang barred H is 2.6. Ang area is 0.54. So, we have 13.77 or 13.8 kilonewtons. What is the location of the center of pressure from the vertex of the gate? This is the center of pressure. Meron tayong eccentricity. This is the vertex. The center of pressure yung kinapanong. So, ito yan. So, that's 0.6 plus our eccentricity. Yung tawag sa eccentricity dito. Okay. May formula tayo sa eccentricity. That's inertia over area barred y. For inertia is ito. Area is 0.54. Ang barred y is 2.6. 0.0173 meters. But that's not the question. Ang inaanap galing sa vertex. Distance from the vertex will be 0.6 plus our eccentricity. Then yung answer is 0.6172. That will be letter A. Obtain the normal force at the vertex. Open the gate if the gate is hinged at the bottom. I-hinge daw yung bottom, so that's our base. Normal force at the vertex. So, tawagin ko siyang T. When we say normal force, it is perpendicular to the gate. Okay? With that, if you want to solve for P, then hinge to dito, ang gagawin lang po natin is magno-moment tayo sa H. May sa no moment about the hinge is equal to 0. Very simple. Observe that we will be needing this distance. If that is 0.6, So, 0.9 minus 0.6 ito 0.P. Ang moment sa hinge ha, ang force clockwise, hydrostatic force clockwise. F times, ano yung moment arm niya papunta sa H? That will be 0.3 minus x into P. Ang P counterclockwise, minus P. Ang moment arm niya, distance galing dito papunta doon. That will be a total of 0.9 meters. Equals 0. So, when F equals 13.77, eccentricity equals to 0.173, then the normal force required to open the gate, it is equal to 4.325 kilonewtons.